Thanks for joining us today. I'll let people settle in a little bit, but today we'll be talking about building real-time data architecture for AI chat. And so I am Nicolas, and I'll be talking with Kundan today. So I'm the CTO and co-founder for Fiveonefour, and what we do is we build dev tools for making the data analytics really easy to use. So one of the things that you're going to see today is one of those tools that we built, which is called Moose. So before diving into this, I'm going to be showing code, and it's like a big application, and I have about 15 minutes to walk you through this, so it's going to be quite fast. But as this is all open source, I'm going to flash at the end the link to the repo. If you want to check it out, go check it out. But as an FYI, everything is open source, so you should be able to see through things. So what's the application that we're going to look at today? So this is the application. I'll make it full screen so that you can see it more easily. Yeah, I think that's fine. So here on the right, you have an AI chat that's like running on my local machine. And then here you have a few dashboards. So you basically have 3 sources of data in this application, this sample application. You have OLTP type of data, so that's like your ACID, Postgres, transactional data. You have an OLAP storage, and then you have a search engine like Elasticsearch. The way this application is built is like this. So yeah, that's big enough. Basically, you have transactional backend. So like here in this app, this is Supabase that's being built here. You have analytical database, which in this case is ClickHouse. And then you have a bunch of services for making the link between the OLTP storage and OLAP storage. So here we are building a chat analytics application. So what's a chat analytics application? It is here I'm going to ask, I have pre-built prompts, and I'm going to ask to compute statistical analysis about the data that's in my OLTP storage. And so when I do that, which is like the perks of a live demo is like you hope that everything is working properly. Oh, I'm on the wrong network. It switched back. I need to be on my iPhone. Okay, so I'll switch that quickly. Refresh, restart this. And now it's working. Okay, cool. So it's like API, Anthropic API is live call, so need to have the internet. So here we're doing live queries to ClickHouse, and we're making aggregation queries. In those kind of settings, you kind of need to have a very fast database, hence why you don't want to run this into your OLTP Postgres type of workloads. You don't want to bring that down through very deep aggregations. So the way we've built this is, I'll walk you through the code directly. So here, this is the repo that I showed you earlier. So ARIA code, like I said, it's available on GitHub. So if you want to clone it and dig into it on how this is built, feel free to do so. UFA is the app that I just showed. And here it's a monorepo type of setup where you have your web app that's here. That's the Next.js app. I won't go deep into that because that's not the subject of this talk. And then you have services here that I flashed earlier. So the Elasticsearch service, I'll leave that out because we're not interested by this. Transactional, this is our OLTP service. So think of it as like your transactional service on top of Postgres. So here that's Supabase. The sync service is the service that will watch for the CDC changes in the database and then propagate those to the analytical service. And the analytical service has ingestion pipelines, which will take in the CDC data, put it into Postgres, and then display the different APIs that you can see in this application that are powering these dashboards and the AI chat. So how is that code structured? So first, I'll start with CDC data ingestion and propagation, like the service that's consuming that data. So here, this is TypeScript. So for people that are doing data and streaming, that must be a little bit surprising. So this is basically doing data modeling in TypeScript. And the goal is you can use the same data model throughout your app. So both on the front end, on the back end, like your backend services, and we'll handle all the pipelinings through the TypeScript data models. So here I'm declaring a foo data model, and then I'm extending it through TypeScript to add some CDC operations on top of it. And that is going to be the data that's going to land in my system. So here, you're going to be able, yeah, that's big enough. You're going to be able to see the pipeline where we are generating a table. We have a stream, which is powered by StreamNative, and then an HTTP ingestion endpoint. So what I'm going to do now is show you a little bit like what the experience of building this is, and like what does our framework does behind the scene. Our framework is called Moose, and what it does like to help you build those things. So first thing is we need a table, and so I prepared some code here. So when I'm gonna uncomment this, like what's gonna happen is Moose is gonna see, oh, the user added a new table in the system, a little bit like Terraform, and is gonna instantiate a new tables behind the scenes with the proper schema that corresponds to the schema that you've defined in the TypeScript interface. So I'm gonna save this. I'm gonna go here, and here you're gonna see we're processing, and then we just created a new table. This is fully local, so that's like your dev experience locally of changing the code, seeing direct feedback, a little bit like what you do in a Next.js application and on the web. You change your components, your code, it hot reloads, and then you see your new UI. It's the same principles here for the data analytics stack. So now I want to connect this table and land some data from a stream to it. So have another little sample code that I'm going to be able to put here. And basically here what I'm saying is I want a new stream to be instantiated. The schema that's in that stream is foo with CDC. And then I want that data to land into this table every time something is being published on that stream. So if now I go to my changes, I can see that two things got created, both the topic, which is like created on Kafka-like compatible infrastructure, and a synchronization process between that topic and the table. So every time a record is going to land on that topic, then it's going to be replicated to a table. And then finally, what I'm going to add is going to be an ingest API. So I'm going to do this here. And then when I go back in the code, we're going to see the changelog saying, hey, I added an API endpoint. So basically, with those 4 lines of code are equivalent to this, which is doing the same thing behind the scenes. But it gives you an HTTP endpoint that's hooked up, that's written in Rust, so like high performance, that's pushing data to a Kafka topic, infrastructure of your choice, so StreamNative or others. And then that Kafka topic, we have a subscription on it that will enable you to send data to the table. We have a bunch of functionality here where you can like add streaming functions that like can be built on top of your streaming data. You can start orchestrate different workflows. There's other examples in the repo. I won't go into too much details here, but basically what we've done right now is created a pipeline that enables you to land data from HTTP all the way to your all app storage in a couple lines of code. And I can show you this working through this. So this is a curl request that's going to push data to a deployed version of this service that I just showed you. So that's working. And then I can do the same thing for, no, not this one, for getting the data back, which is this, and that's working as well. So basically, like what I've hit is this remote deployment for this service, and I've hit it here, and now like the data has gone through. So if I go to settings here, like this is like I've deployed this connected to StreamNative directly. So that's like you can work with the Kafka provider of your choice. The last thing that I want to show you is we have the ability to see changes before you ship them to prod. So here I made a few changes. It's a little bit like Terraform here, but specialized for the data infrastructure, where you're able to see like the differences of the things that you ship. And so here, if I do Moose Plan, which is a little bit like Terraform Preview, if you're familiar with that, I'm going to be able to see the changes that I made locally. And next time I push to prod, it would create a new topic, create a table with a schema that I've defined, and the syncing process, as well as the API endpoint. So it's supposed to be like a very quick and iterative process with which you can go from dev to production really quickly, and then you get like full visibility into all the changes that are made to your infrastructure. And now I'll hand it off to Kundan to talk a little bit about the StreamNative part.
Which one is the cluster?
Yeah.
That one, and that's the deck.
Yep.
Okay, cool. Sounds good. Awesome. Thank you. All right. So quickly, so let me just continuing the extension of what he showed in his flow. I think I'm just bringing the context of Kafka compatibility, and StreamNative comes in here because we are Kafka compatible. So it's within a matter of seconds, he was able to create a serverless cluster and grab some of the access points and plug into his framework, and that allowed him to kind of create topics into that. I'm going to just bring up one slide for the benefit of folks who don't know about StreamNative. I'm just going to quickly cover what this platform is. So StreamNative essentially at the core really offers support for Pulsar and Kafka. The infrastructure is Pulsar, but essentially we are Kafka compatible, so all your Kafka applications can read and write data in and out of StreamNative Cloud. We have connectors for both Kafka Connect and Pulsar IO. These are two different frameworks specific to the respective underlying frameworks, but it doesn't matter for you to use. You can basically log into StreamNative Cloud and create a pipeline using a combination of connectors. Like you can say source could be Pulsar connector, sync could be Kafka connector, based on what you want to use. The libraries will work we have libraries for both, in case if you want to write custom code using Pulsar or Kafka. This is really where, for some of the folks who must have seen the keynote today morning, we've really announced some of the Lakehouse storage enhancements. This is essentially where we are able to stream data directly to object storage and then write topic data as tables of the most popular open table formats. Right? We support different types of processing engines. Flink is something which we also offer as a managed Flink service in partnership with Viverica. We OEM their engine in our cloud and make it available as a fully managed service within StreamNative Cloud. But besides that, we work with other processing engines as well. We have our own Pulsar functions, which are part of Pulsar, lightweight way to process the data which comes into StreamNative Cloud using the most popular, the common popular language runtimes like Java, Python, Go, and others, right? We support multiple protocols. So that's a little bit about StreamNative for the folks who don't know about it. We support different types of deployment options, right? Serverless and dedicated are run in our cloud account. BYFC runs in customer's cloud account. Private cloud is self-managed or in cloud. Now, that's a little bit about that. Let me just go back to the flow here. And I think in the cluster, what you'll notice is let me just come back actually to the root. This is essentially the cluster where you would typically go to a StreamNative cluster where you can grab the access points. These are the access points which are wired into the Moose framework, right? And now let me just quickly go to the topics where actually all that data is actually getting populated. So if I were to jump into that, still getting loaded. I'm just going to pick some topic here. This is where I think all the messages which are wired via that framework, Moose framework. Actually, we don't have a framework. Let me just go back to the previous topic. Give me 1 second. Let's try the second topic here, where I already have a subscription for. So I think I can do a quick sneak peek of the data which is getting populated from Moose's framework. And this is where it'll all show up, right? So again, I'm only trying to show the connectivity of what he started and as data streaming into a Kafka-compatible service like StreamNative Cloud. And then, of course, their pipeline can do more and fetch data from here and take it further, right? So that's pretty much from the StreamNative context. I'll hand it back to you. Yeah, thank you.
So in terms of, that's like pretty much like what we had to show you today. So like what we went through, like to recap, is a very quick overview of this architecture with transactional backend, replication, data landing into an analytical backend through streaming, like and a buffer here. That went through like StreamNative's like infrastructure. So Boreal is our hosting there, where like we can play well with StreamNative. And the code is open source. So I'm gonna flash the latest slide, which is here. So if you're interested in like learning, no, that's not the right button. Learning more about the architecture, go to 514 labs/area code. This is like the code base that I walked through is there. So you can get up and running very quickly by yourself there. Moose is open source, so it's like fully free to use, MIT licensed. So if you're curious about it, go check it out. And if you have any questions, I'll take questions now. And yeah, I'll hang out after as well.
Can you talk more about the cloud and the cloud platform?
Sure, I can show you more about the cloud platform as well. So basically, what we do here is we host a Moose project. So by default, actually, I can show you a little bit quickly how you get started. But so when you create a new project here, it's like very much like Vercel type of workflow, where you point to a Moose project and then we're going to deploy it for you. We deploy the infrastructure. And you can choose to either go managed infrastructure, where we're going to manage for you a Kafka cluster, a Kafka-compatible cluster, and a ClickHouse cluster, or you can choose to bring your own and like connect StreamNative, for example, in there. So here, if I'm just going to go with this, then I can choose here, and then I can. That's what I did for configuring my StreamNative clusters. I started like putting the information here for the Kafka instance, and then I can just go through and use external, or I can use like the managed instance directly here. So if you want to deploy right from here, you can, and then we'll manage all the infrastructure for you behind the scenes. And so here, like you have metrics about everything that's happening in your application. So that's ingestion, HTTP ingestion endpoints, the streams that are running, functions that are getting run, analytics API that are getting called. So all the stuff that I did live is getting registered in the framework here as well. Any other question? This one wasn't planted, I swear.
How do people interface with like stream processors?
Okay, that's a great question. So you have, actually, I can live show you. The question was, how do people interface with streams in the framework? So those are Kafka streams, right? So if you have your Kafka client and you want to start publishing or subscribing to streams, you can do that. Like, you're fully able to do this. We also provide like some helpers. So here, for example, I can do stream at consumer, and then here I put like just a function, which is like, let's just say event, and you get like all the autocomplete here. So I'm in cursor, so it does a bunch of magic, but everything in the TypeScript SDK is very statically and deeply typed. So the interface that you set here, which defines the interface that's like the data that's landing in your database, is also the interface that's defined in your stream. So by definition here through the code, we enforce that both the data that's going through the stream and the data that's going to be landing in the table have to be the same. Like, otherwise you're going to have a compilation error, and like you're not going to be able to go through it. And so like another advantage of this is like when you have a consumer here, directly you get autocomplete on the types of the data that's going to go through. And so if you want to start, so a consumer is just a function that's going to consume data and then can do side effects. So it can push data to another API. It can make calls to Redis if you want to for like caching things. But you can also do transformation on the data, which we called transforms, very original. And then like you can return some more data. And then if you want to change it and say like, for example, I want to add a field to it. So I'm going to copy everything. And then add like a CDC timestamp to it. Then here it's complaining because I'm missing some arguments. Yeah, I'm missing like the destination data to put into things. So here it's telling me, oh, you're adding a transformation, but you're not telling me where you actually want to send the data to. So I can make a new stream, super easy. Destination stream, stream, yeah, like I'm gonna call it that. And then it's like we can check which argument this is, and now this should start to be happy. It's not happy about the return type assignment void. Yes, so it's not happy about the return type. So now it says like, oh, actually, like you need to put something that's not void. And so now it should start to be happier. Well, no, actually it's not. But like basically that's putting into practice exactly what I told you earlier, is like this is statically typed. So it's telling me, oh, you're missing, you actually are mismatching the property that you had. So CDC timestamped existing on my return type, and I'm making it a string when it should be a date, and so it's complaining about it. But now if I return a date, it's all happy. So that's how you interact with streams. Like you can consume data this way, transform it, then it's going to put it back into another stream. It's purely developing TypeScript code, but it has like it deploys your infrastructure, instantiates your streams, and then your streaming functions are all hooked up directly. Other question? We might be out of time. Yeah. Okay, so I don't have more time. If you have more questions, I'm going to be hanging all day around, so you can find me with my hat, my Fiveonefour hat, and I'll be very happy to answer any question you have. Thanks for listening.